Hello and welcome to the RTTS presentation, What is a data warehouse and how do I test it? It is great information for testers on data warehouses, ETL and business intelligence, and how to test them. Our speaker today will be Bill Haydock. Bill is the founder and president of RTTS. Let's welcome Bill Haydock.
Thank you very much for the introduction. Welcome to What is a data warehouse and how do I test it? My name is Bill Haydock. I'm president of RTTS. Just a brief intro about RTTS. We're the leading provider of software quality for business applications. We're founded in 1996. We have offices in New York and Atlanta, Philly and Phoenix. Our geographic region is all over the world. Our customer profile is the Fortune 1000, and we have strategic alliances with HP, IBM, Microsoft, and Oracle. And the software that we deliver is Query Surge, which is a data warehouse testing tool, and Tomos ALM, which is application lifecycle management in the cloud. Okay, here's an overview of the topics we're going to cover. They are: what is big data? What is a data warehouse? What is business intelligence? Testing the data warehouse architecture, testing business intelligence, and then we'll go over a brief summary. What is big data? Well, big data is one of the biggest buzzwords of 2012, so let's take a look at what big data is. What is big data? Well, big data is being defined as too much volume, velocity, and variability to work on a normal database. Volume is the size of the data, velocity is the speed and complexity of the data, and variability is the different types of data. Big data has been defined as 5 petabytes or more, where a petabyte is 1,000 terabytes, and 1,000 terabytes is 1,000,000 gigabytes. 1,000,000 gigabytes is 1,000,000,000 megabytes. That's some large size. According to the EMC COO, the market for big data is $70 billion a year and growing at 15% per year. Okay, let's look at the impact of big data. Walmart handles more than 1 million customer transactions every hour. The data imported into its databases contains more than 2.5 petabytes of data, which is the equivalent of 167 times the information in the U.S. Library of Congress. Some other instances: Facebook handles 40 billion photos. Twitter processes 85 million tweets per day. Google processes a terabyte per hour. And eBay processes 80 terabytes per day. Let's go over some of the technological solutions that are out there to process large quantities of data with big data. One of them is massively parallel processing databases such as Hadoop. Others are data warehouses, data mining grids, distributed file systems, cloud, the internet, and other technologies that are being used. So let's look at what a data warehouse actually is. What is a data warehouse? Well, a data warehouse is typically a relational database that's designed for query and analysis rather than for transaction processing. A data warehouse could be a group of cue cards, a whole stack of them, but typically it's a relational database. It's also a place where historical data is stored, contains either raw data or formatted data, and combines data from multiple sources such as sales databases and operational data, human resource data, etc. The business case for building a data warehouse is that data that's stored in operational systems, which are also known as online transaction processing or OLTP systems, is not easily accessible. It was not designed for that. Also, OLTP systems are not designed for end-user analysis of any kind, and the data in these systems is constantly changing. And it may be deficient in historical data. Also, diverse forms of data stored in different platforms or in dissimilar formats. The data warehouse solution, as it's currently incorporated, collects data from other sources, as we spoke about before, integrates it into logical business areas, and then provides access to the users of this information through business intelligence tools. So let's look at the data warehouse data. Data in a data warehouse is subject-oriented, which means that it's historical and design aid decision-making, as opposed to online transaction processing data, which is application oriented. It's integrated, which means it comes from different operational systems. It's non-volatile, which means the data should not change. And it's time variant, which means a data warehouse focuses on change over time. Okay, let's look at what ETL is. ETL stands for extract, transform, and load. So why do we need an ETL process? Because we need to load the data warehouse regularly from different file formats, different database formats, and it needs to be extracted from all these different formats. When we extract it from one or more OLTP systems and copied into the data warehouse, and then it's transformed, removing inconsistencies, and assembled to a common format. And then it's loaded into the data warehouse. So extract, transform, and load. Probably the king of the ETL software is Informatica. Here's a graphical view of how the ETL process works. We have our source data, whether it be legacy databases or other kinds of databases. We have files, we have XML. That's where we're pulling the data from into the extract, transform, load process, and then loading the data into the target data warehouse. Okay, the marketplace for the data warehouse is approximately $13 billion in revenue and has increased at an annual rate of 11.5% according to consulting firm the 451 Group. Data warehouse size is small ones considered under 5 terabytes. A mid-size warehouse is 5 to 20 terabytes, and a large data warehouse is over 20 terabytes. And the leaders in the data warehouse management systems are Teradata, Oracle, IBM, Greenplum, Sybase, and Microsoft SQL Server, in that order, according to Gartner's Magic Quadrant for data warehouses. There's different delivery models for data warehouses. There's your standalone DBMS software, which is very similar to your enterprise software that you install on the server and operating system of your choice. There's cloud offerings, and then there's what's really hot, which are data warehouse appliances. The leading appliance makers out there right now are Exadata from Oracle, Netezza, which was purchased by IBM recently, and Teradata. And in the picture you can see Larry Ellison, the CEO of Oracle, standing next to an Exadata appliance, which is the Oracle software for data warehouse running on the Sun operating system and on an Oracle box. And that gives it some scale. You could see that it's Larry Ellison is probably 6 feet tall. It's a little bit bigger than him. Let's talk about business intelligence. Business intelligence is software that is used in spotting, digging out, and analyzing business data. It's pretty much a reporting engine on steroids. It provides access to data, which can be used in day-to-day operations and used by your run-of-the-mill users. And it provides historical, current, and predictive views of business operations. Companies use business intelligence to improve their decision-making, cut costs, and identify new business opportunities. And with today's BI tools, users really can jump in and start analyzing data themselves, rather waiting for IT to run their complex reports. And it's made up of several related activities, including data mining, online analytical processing, querying, and reporting. Let's take a look at who's using it. Well, Walmart uses vast amounts of data every day to review their processes and their purchasing habits and to really dominate the industry. Amazon and Yahoo use it to look at how people react on their websites. And the fast food chains such as Hardee's and Wendy's, TGI Fridays, Ruby Tuesdays, they're big users of BI software. They use it to make strategic decisions such as what new products to add to their menus, which dishes to remove, and which are underperforming as far as stores go. And because they're so operations driven, BI is really central to them. Okay, let's look at business intelligence and data marts. Data mart's also part of the data warehouse architecture. Has similar characteristics to a data warehouse, but it's smaller and more focused either on a division or work group. and they hold aggregated data that's pulled from a data warehouse, and some of it has granular data, but more of it's aggregated. Business intelligence tools sit on top of the data marts. So now you're looking at our scaled down architecture, your source data being pulled into the ETL process to your target data warehouse to another ETL process being pulled into a data mart. So the business intelligence software sits on top of the data mart. And one of the characteristics of the BI tools is that most of them have a really slick dashboards to make it easy for users to see and evaluate different areas that they want to quickly. Again, they're using this to make strategic decisions on their business. Let's look at the marketplace for business intelligence. Worldwide business intelligence platform, analytic applications, etc., has reached $10 billion in 2010. There's pretty much four major players here. There's SAP, Oracle, IBM, and Microsoft, and they own 60% of the market share, according to Gartner. The leaders there are, according to the Forrester Wave, is Cognos, which was purchased by IBM. They're number one. Business Objects, which is owned by SAP, is number two. Oracle's number three. Information Builder is number four, followed by SAS, Microsoft, MicroStrategy, and ClickTech, which is a new entrant. Now let's look at testing and data warehouse architecture. There's quite a few resources involved. They're typical of most development and testing projects. You have your business analysts who create requirements. You have your QA testers who are there to develop and execute test plans and test cases. You have your architects that set up the environments. Your developers perform unit tests. Your DBAs test for performance and stress. And your business users perform user acceptance tests. Now, as you can see in red, the QA testers do need strong SQL skills to execute these tests. And for the purpose of this presentation, the strategy for testing data warehouse will focus on the role of the tester themselves. So, we feel that an effective way of testing, or the testing strategy for going after data warehouse architecture, is you have to look at the sources, the ETL layer, the data warehouse itself, and the business intelligence front end. And we're going to talk about entry points. We feel the best strategy to do is test every entry point in the system. And this will provide rapid localization of data entry between the points. And each unit must be treated separately and in combination, since there may be multiple components in each. So here you see source data again to ETL process to target data warehouse to another ETL process to data mart to the business intelligence software. And here are your test entry points. And going from one test entry point to another is called a leg. Okay, let's look at an architecture that probably looks a lot more like the architecture that you would be testing on your site, where you have 6 source databases or files going through 6 ETL processes, going into 6 staging databases, through 6 more ETL processes into the target data warehouse. That's a lot of test entry points. Then the data warehouse going to 2 more ETL processes, to 2 data marts, to 2 installs of business intelligence software. So that's a lot of different test entry points, as you can see right here. It can get very complex and be a lot of work to test all this data. When you're testing a data warehouse, the key artifact is called a mapping document, also known as source to target map. It's the critical element required to effectively plan the ETL process. And the intention of this document is to capture your business rules, your data flow mapping, and your data movement requirements. The doc specifies your source input definition, your target output details, your transformations, and your data quality requirements. Here's a sample of a mapping document in Excel. You can see up top the headers we have there are the mapping number, the mapping name, the source tables that it relates to, the target table, the transformation logic from the source, and the transformation logic for the target. And then the testers have added in 2 sequels for mapping number 12, one at the source and one at the target. Here's what those sequels look like in more detail. They're not simple. Again, testers need to be trained and skilled in writing SQL. So the implementation of testing a data warehouse, here's what's going on in the marketplace. We see a lot of manual execution, we see automated execution with your standard test tools, and we see bulk automation with the data warehouse test tool. The manual testing flow looks a little bit like this, where you either have your mapping document in Word or Excel, and then you write your SQL and your favorite SQL editor, whether it be Toad or Squirrel or whatever comes with your data warehouse tool. Then you run your tests. Then you dump the results of your tests from your SQL that's pulling from your target and your source to a file. And then you either compare the results manually or with a compare tool. Now this could take a lot of time doing it manually because it could be hundreds of thousands of rows that come back. And then people typically will enter their defects or issues into whatever their favorite defect tracker is. And then iterate. Here are some manual ETL testing flow comments that I have. First is checkpoints across each leg so that each transformation is checked. The second is if you're using a file compare tool, make sure that the result rows for each query are in the same order. In other words, the database is under no obligation to return rows in a specified order, so you have to make sure you do this in SQL. The process can result in hundreds of thousands of source and target query pairs or hundreds of thousands of rows. And it's very labor intensive. Even with multiple people, there's going to be a very small sampling that can be performed. And by very small, I mean much less than 0.1% of all the data. The other thing we see out there is functional automation. And the test flow for that is similar to the previous one. You extract mappings from the mapping document, you write your pair of queries, you issue the queries via functional automation tool at your target and source. You have the functional scripts dump the query result set files to files. You compare the files either by writing automation code or by using a file compare tool. But this process is really dependent on the speed of the automation tool. Normally only a fraction of data can be covered, and by that I mean 1/10 to 1/4%. And these tools are really not built, the tools from IBM and HP and the other vendors are not built to handle this kind of a test. So a lot of times you'll have memory issues where the tool will fail or get corrupted. And then there's data warehouse testing tools, an example of which would be Query Surge that we built, that is the only test tool built specifically for data warehouse testing. It has a web-based architecture, as you can see with the user. It has agents that execute the test. It has an app server and a database server, and pretty much supports any JDBC compliant database or data warehouse. Query Surge has 4 main modules, the first one being the design library, where you create your query pairs or the queries that go at your target and source. It has reusable query snippets or functions, and it's where you manage your query pairs. Query Surge also has a scheduling module where you build test scenario, which are groups of query pairs, and you build and schedule your test suites that can run immediately or at any time at night or day. We have a runtime dashboard that allows you to see real-time execution view and real-time results, and deep dive reporting that allows you to analyze and drill down into test results, look at all failures, show audit history, and lots of other goodies. So here's how something like that works. The user fires off queries, one at the source and one at the target. It pulls back all the data, which might be hundreds of thousands or millions of rows. A tool like Query Surge will do all the compares for you very, very quickly, and I mean in a matter of minutes, and flag any differences in any text anywhere, and then you launch it and at the next leg of the data warehouse process. A data warehouse test tool built specifically for data warehouse testing will validate up to 100% of all data quickly. It'll provide a huge increase in coverage and verification of your data, and it'll tremendously decrease your testing time and cost while providing huge ROI. Now let's look at testing of business intelligence. The strategy would be to execute business user reports and verify the results from the report to the data mart. So between those two legs. And you want to look at all logical calculations by creating queries to do that. You want to verify data validations to the back end again by creating queries that incorporate and return the equivalent data. And you want to do parameter validation, so reports that have parameters in it, like a from date and to date. You want to create tests that incorporate. So functional testing and business intelligence, the developer creates reports based on business user requirements, then verify reports by running reports using a range of parameters, and verify the data is correct. And you can and should use your typical automation tools to do this. On the performance side, some of the challenges are that BI systems often have reports that have complex queries that bring back hundreds of thousands of rows from lots of different databases. And the challenge is determining performance characteristics under different workloads and conditions. So you need to know the ability of the system to scale the number of concurrent users you're expecting, and how much time for each user to retrieve the report they need, depending on their parameters. The strategy is to determine your typical workload, identify your user roles and what they do and how often they do it, determine how many users for each role there are, choose a performance tool, whether it be Load Runner or IBM Performance Test or whatever tool can capture the protocol that you need, create scripts by recording the protocol traffic, and then modify those scripts, and then prepare your concurrent multi-user tests. And make sure each user emulates the activity of real users. Then what you want to do is you want to monitor response time, throughput, network activity, and system activity, which is typical of any performance scalability test, and review your results and provide recommendations. And if you do it this way, you'll pretty much reproduce the workload activity of the entire population of the BI users. So in summary, big data is a growing concern and has reached over 70 billion in scope. The data warehouse and BI intelligence marketplace is a $22 million marketplace and growing. Functional testing of data warehouse is very complex because it requires strong SQL skills, and it's typically manual. And these manual or automated using standard tools provide a very small percent of coverage, which means there's a lot of risk involved. Really, you need to do bulk data automation. And we showed you that query search can do something like that. BI software has to be properly tested for both functionality and performance. And with BI software, you can use your traditional functional. Okay, well, that pretty much covers it. We've thrown up some other areas of interest here. Our query search website, if you want information on data warehouse testing and data automation tools for the data warehouse, you can go there. RTTS, our parent site, has tons and tons of offerings, white papers, case studies on a whole host of different topics. And then for one specific to data warehousing and ETL process, you can go to the Query Search Resource Center. Thank you very much.